the HAWE Tech Podcast.
Hello, my name is Ahmed and I work as Key Market Manager at HAWE. Today we will talk about how pressure control can be realized with a servo motor pump unit. For this podcast, I invited my colleague Bernhard, who works as an application engineer by HAWE. Welcome, Bernhard.
Hello and welcome from my side as well.
Bernhard, since ages we are using pressure control valves in hydraulic systems. Let me ask you first, where do you use pressure valves?
Let's take, for example, a clamping device. The hydraulic mostly consists of a pump, valves and an actuator. And for getting various clamping forces, you need various pressures in order not to damage the material, for example. This is a typical application where you would use a pressure control valve in order to get the different levels of pressure you require for the application.
Mm-hmm. Okay. This is also well known and state of the art. Let me ask you, is there any other way to control pressure in hydraulics rather than pressure control valves?
Yes, of course. You can do that without any valve while using a servo motor pump unit.
Oh, very interesting. Could you please explain to us what is a servo motor pump unit?
A servo motor pump unit consists of a servo motor who is able to rotate at variable speeds, starting with 0 revolutions. The servo motor drives a pump with a constant displacement. So by the variation of the motor speed, you can vary the pump flow.
Mm-hmm. Can I also control the maximum pressure in the system?
Actually, the servo motor is not only able to vary the speed, but as well the torque on the motor shaft.
Mm-hmm.
But I will explain that later.
Great. So now we have a system where the servo motor pump unit can vary the speed and the pressure. But what does that mean for the pressure control, please?
Now, as we heard, the pump is driven by the servo motor.
Mm.
And every servo motor needs an inverter to get into operation. Now, for example, if the machine controller gets a signal from the pressure sensor that the pressure is too high, the servo motor will reduce the speed, the pump flow will go down, and this will result in a lower pressure. Mm-hmm. Or the other way around, if the pressure is too low, he will rise the speed, therefore rise the volume flow. This results again in a higher pressure.
Mm-hmm.
And secondly, if there is a function of a pressure limitation in the system, we're having a simple relation between the inverter, the motor and the pump. The higher the current from the inverter to the motor, the bigger the motor torque and the higher the pressure. That means if you limit the current to the motor, you can limit the achievable pressure in the system.
Okay, I got it now. So the relation is current, torque, and pressure. But how is the pressure control with a servo motor pump unit is done in reality? Can you give us an example, please?
Let's stay at the clamping device mentioned before. We now have the hydraulics is now consisting of a servo motor pump unit with an inverter, a pressure sensor, and the actuator of the clamping device. Now, as I said, you limit the pressure by the limitation of the current to the motor on one side. And on the other side, the pressure control is done by the variation of the speed of motor and pump.
Okay. One more question came in my mind. Which advantages does pressure regulation by a servo motor pump unit have, actually?
There are a few big advantages. In principle, the servo motor power unit is an excellent pressure controller, and it's working very dynamical. In fact, this unit is creating just the amount of hydraulic flow and the level of pressure you need at that moment.
Mm-hmm.
Furthermore, you don't need any additional valve and this makes it very efficient from the hydraulic side. Low hydraulic losses result in low heat in the system, and this give you a small oil volume, a small tank, and you don't need any additional cooler, of course. And one more advantage is that a variable speed system like the servo motor power unit is very efficient in the meaning of noise emission. That means it's much less noise emission than compared to a system with a constant speed, running at constant speed.
This was actually my next question. Can we have the same function, the same advantages with a normal asynchronous motor, which is commonly used in power backs?
Actually not, Ahmed, because the asynchronous motor is not dynamic enough. So it's not able to vary at the speed in that short of time or so quick as it is required.
Okay. So now we heard about how a servo motor pump unit can work. Can you give us some examples from the applications you face on a daily basis?
Yes, one application is, for example, for press brakes. In a press brake, you want to bend sheet metal, and you bend sheet metal of different kind of sizes and different thicknesses, and therefore you need various kind of pressure levels. That is where we can use this servo motor power unit, pump unit, extremely good, and it is very energy efficient, and it replaces, for example, a proportional pressure valve. A second application is for injection molding machines, where we drive the injection nozzle at various speeds and at various pressures required for the application.
Very interesting applications. We came to the end of our podcast. Thank you very much for listening. I would like to sum it up again, the advantages of the servo motor pump unit. With the servo motor pump unit, you can easily control the pressure according to the requirements of the application without any valves. That makes the system simple and very energy efficient. That leads to a small oil volume, low noise, and you do not need any additional cooling. This, of course, aligns with the HAWE philosophy to offer the customer sustainable products with low CO2 emissions. Thank you again for listening, and if you have any ideas for other podcasts or any questions, please send us emails at podcast@hawe.de. Thank you very much. Thank you, Bernhard.
Thank you for listening from my side as well. Till next time at HAWE Podcast.